Hello, students. Welcome back. We are on day, I believe, 13. Again, I think my numbers are a little off up here. But again, we are continuing. We finished yesterday. We almost finished page 15 of our notes, going over the different types of plate boundaries. And we didn't have enough time to go over the third one. So we're going to go ahead and include it in our Go Blue. Again, the title of page 15 should be Plate Boundaries. We have divergent boundary, as you can see here. We have a convergent boundary, as you can see here in the middle. And then next we'll be talking about transform boundaries. Again, make sure to draw each of these. Pause video as you see fit. Again, draw those arrows and boxes in the structures. I have a mountain for convergent. I have some magma for my divergent. And for transform, I just have a little fault line, maybe a little difficult to see, as you can see with there. That is going to be page 15. And then later today, we are going to begin page 17, which is going to be a little more in depth. We'll talk about that in a second, but the title of that is going to be Convergent Boundary Types. Convergent Boundary Types. Again, convergent boundary types. So we're going to be combining our two different types of crust, as you'll see here. Okay, so for number 16, we're going to compare and contrast the three different types of plate boundaries. For number 16, on page 16, we're writing this Go Blue on page 16. And then what structures do the three plate boundaries create? So go ahead and make sure you write those questions down for our notebook check coming up this Friday. Announcements, guys, again, we have a notebook check Friday. We got a unit quiz Friday. And we've got the vocab due Friday. So a lot coming up. Get those grades up to date. Get with your assignments that are missing because the quarter ends next Friday. So you got to make sure you're all up to date and all set with that. All right, pause this video, answer those questions. Let's take a look what we got. Okay, we talked about divergent, plates move apart, and the new crust forms, thus why we see the magma. Okay, and then for convergent, plates move together, it's just the opposite. Whereas instead of getting the new crust from the magma, we're going to be getting the crust being destroyed when it becomes mountains, right? So old crust gets destroyed. It gets crumpled up, broken apart, and fractured. Now, for transform, I want you guys to go back to page 15. Okay, and go back to page 15, and I want you guys to fill this out for transform very briefly because we didn't have time for it yesterday. Okay, for transform, we're going to answer that question right now. You guys are going to tell me here what's in yellow, right? For that one and the third one on page 15, okay, transform, it's a region where two plates are going to slide horizontally. They're going to move side to side, sideways. Okay, now the crust doesn't form. It doesn't get destroyed. It just gets slightly fractured. Just gets slightly deformed, slightly fractured. For our produces here, you're going to put earthquakes and faults. Again, when two plates move side to side, like friction, when your hands move back and forth, that's going to cause an earthquake or cause what we call a fault line. A fault line. We can see some movie images of it here, illustrations, as well as maybe some satellite imagery as well there. Okay, so we kind of gave away some of the stuff for our transform. Again, plates move horizontally or sideways, and crust just gets to form. Now, we got to know for number 2, what structures does each create? So if you go back to page 15, you'll see all the answers for that. Divergent, we get mid-ocean ridges and rift valleys. Here's a neat picture of a rift valley here, just mountains kind of pulling apart there, right? We get a little river at the bottom there, bodies of water. Next, we get convergent. Again, we get full mountains when plates come together. Sometimes land volcanoes and island arcs. So convergent, we get island volcanoes, land volcanoes, and mountains. And lastly, I just gave you the transform example. We're going to get earthquakes and faults, guys. Earthquakes and faults when those plates move side to side. Let's go and continue, guys. Again, you're going to put down 16 and 17 plate boundaries too. We're going to go ahead and set up page 17. I looked at the video from yesterday, and it looked like the lettering here comes, it appears to be on the right side when it shows in the YouTube video. So maybe we'll see if we can do it this way. And then again, vocab due on Tuesday. So let's go ahead, guys, for our 3 categories of our convergent boundary types. Again, here's some. Again, if there's ever an earthquake, you do not want to be driving. You do not want to be driving. All right. Nope, we're gonna skip that. Oh, dang it. Okay. Well, let's try anyway. Which historical figure was a map maker and claimed that the continents fit together like puzzle pieces? This is an old question. You guys know it. Is it A, Suez, B, Hess, C, Ortelius, or D, Dutoit? Pause the video, think about it, and the answer is going to be Ortelius. On your quiz on Friday, you're going to have to know some of these people's names and what they did. So be prepared to answer questions like this. Okay. Before we get to, do write this question on page 16 on your under your Go Blue that you just wrote. I want you to answer, how did Hawaii's islands form? How did Hawaii's islands form? You can kind of see a little hint there, right, of some of that lava flow, but there's more to it than just the lava flow coming out of the volcanoes in Hawaii, right? And it can become a big problem, as you'll see here in the local area. So let's go ahead, as usual, let's get a little glimpse of that. Okay, again, I'm just going to show 1 minute of this video.
One of the youngest geological formations. These 8 tropical islands are one of the youngest geological formations on the planet. The investigation into how Hawaii was formed began in 1934. Dutch geophysicist Felix Menes was able to calculate the gravitational forces at work on the Big Island, and using this data, determine its size. His results revealed that the Big Island was like a gigantic iceberg.
Actually larger than Mount Everest if you measure it from the ocean. It's the biggest mountain in the world. And you'll find out the answer to how it formed on your own. So let's go ahead. Again, you need to watch that on your own. And then also another clip I've got is just kind of example of the problems that this stuff causes. Again, whoever owned that car was not there to save it. You live in Hawaii. Again, important to probably have volcano insurance because the lava flows on the Big Island. And it's gonna, you know, sometimes lose homes and neighborhoods and this and that. So big issue there, right? So I got more, and then here's one of somebody's yard. Lava flow. And that doesn't stop that lava. No, it actually goes over the fence as you see here. So big problem. Again, watch all that first video so you get the answer for that question there. Okay, let's go, guys. What I'm gonna have you do is I just want you to set up page 17, right? We're gonna set up page 17. So what am I gonna have you do? Well, again, can I have all this take the screen? Well, we'll just deal with it. It's gonna be kind of small on the screen, but we'll deal with it, right? Okay, so go ahead, title page 17, convergent boundary types. Convergent boundary types. And again, go ahead, you can pause this as you see fit, no problem. We've got 3 types, okay? We're talking combinations of crust. What are our 2 crusts? Our 2 crusts are the oceanic crust and the continental crust. So here I've got oceanic, and I'm just gonna draw a trench and an island arc volcano, a volcano island arc. So go ahead, pause that video. If it's backwards, I sincerely apologize. I'll show you those titles in a second. And this is page 17. We have 3 categories on page 17. Our second one is going to be oceanic continental. Go ahead and draw another trench underwater and then draw a volcanic mountain range, Okay, and then lastly, we've got continental, and I've just got simple mountains, simple folded mountains, as you see there. Again, 3 categories. Leave the right side open. Okay. Pause the video so you see fit to set up. All right, let me go ahead and minimize my screen. So, let's get started on that. Okay, so for your first category, oceanic, we're combining 2 ocean plates. Again, you're writing this on the right side right here, right side right there. We've got 2 ocean slabs coming together. And again, one's gonna go below the other. And when it does that, it's gonna pull down that ocean floor, which is what's gonna create our trench. And again, for classic volcano islands, like Hawaii, things like that, you're gonna always be oceanic plus oceanic, or oceanic convergent boundaries. So these are, again, combinations of convergent boundaries, okay? Here we have, again, pause the video, get all that down, then what you see in yellow, okay? Here you can see, again, we've got the plate going below, we've got molten rock coming out of that, right? Some more examples. Here's another great example of that as well, those volcano island arcs. All right, last question of the day before we do some more. Oceanic crust is thicker while continental crust is more dense. So we're saying oceanic crust is going to be more expanded, take up more space, whereas continental crust is going to be more compact. Is that A, true, or B, false? And think about it, pause video. This pizza here looks pretty good, makes me a little hungry, but maybe we can have some food later after school today, right? It's going to be B, false. B, false, guys. Again, the oceanic crust is more compact and condensed because it's being pressed down by the ocean, whereas our continental crust is going to be more expanded. My bad if I said the oceanic crust is more compact Continental crust is more expanded because it's just sitting beneath the air. It's kind of like oceanic crust is the crust beneath the sauce and the cheese. Continental crust is the crust that's on the end of the pizza that we grip the pizza with, right? All right. Again, in class we had research time, but we are not going to worry about that because we can't do research. We're doing a different style here with e-learning, right? We'll get to that video another day. How can NASA help us survive a potential super eruption? Next, we'll have oceanic continental, guys. Oceanic continental, that's here in the middle section of page 17. And again, the more dense oceanic slab sinks into the asthenosphere. Okay, it's more dense. So again, the oceanic always goes beneath. Magma begins to develop beneath that because it comes from the mantle a little bit. And what's it going to produce? Super important, guys. We're going to get trenches again, but you can also get, instead of volcano islands, we get volcanic mountains, right? Volcanic mountains. So totally different than our volcano islands. Again, are all volcanoes the same? Are two volcanoes always the same? No, volcanoes are all different. Earthquakes are all different, right? So we get different creations from different structures, right? Okay, so make sure you've got that down, guys. Got that down. Again, oceanic continental, we see the plate, the ocean plate going below and then it melting and those pockets picking up and going into the continental crust, making volcano mountains, right? And we will go ahead and we'll spend another day on trenches. No worries about that. And why not? I'll just show you guys the last one, okay? Continental crust. It's really simple, guys, really simple. We get two continental plates going together. Well, neither of them really go beneath each other. They basically kind of crunch into each other. And when they crunch, when they collide, they're not going to go down. They're going to go up. And when they go up, we are going to get our mountains. Classic mountains, no volcanoes, okay? Folded mountains such as the Himalayas. Students, that concludes our our video lesson of the day. Again, we've got the unit quiz on Friday. We've got the notebook check assignment due Friday. I'll post those two random pages you need to have pictures of and send those to me so I know you're keeping up with your notebook. And we've got the recent Unit 2 Vocab 2 due Friday as well. I'll get the workbook pages up soon. If you have any questions, let me know. Mr. Campbell, grades are fully up to date. I think I've had maybe a few assignments turned in, so I'll update those. But again, we got the end of the quarter next Friday, so make sure you have questions, let me know. I will get to you within 24 hours. Again, Mr. Campbell, signing out.